మ్యాథమెటిక్స్లో చక్కని మార్కులు సాధిస్తే దాని ప్రభావం కేవలం ఇంటర్ మార్కులపైనే కాదు, ఎంసెట్, ఐఐటి లాంటి ఏ ఎంట్రన్స్ రాసినా కనిపిస్తుంది. అందుకే మ్యాథ్స్పై విద్యార్థుల ఫోకస్ ఎక్కువగా ఉంటుంది. మ్యాథ్స్లో సాధించే మార్కులే ఇంటర్ గ్రేడ్ని నిర్దేశిస్తాయి. మరి ఇలాంటి సబ్జెక్ట్ను ఎంత జాగ్రత్తగా ప్రిపేర్ అయితే అంత మంచిది. ఈ దృక్పథంతో ఆలోచించే వారి కోసమే కేబీ టెలివిజన్ అందిస్తోంది ఈ క్లాసెస్. మరి ఇంకేమాత్రం జాప్యం చేయకుండా క్లాస్లోకి ఎంటర్ అయిపోదామా? డియర్ స్టూడెంట్స్, నిన్నటి ఎపిసోడ్లో మ్యాథ్స్ పేపర్ 2Bలో అప్లికేషన్ ఆఫ్ ఇంటిగ్రేషన్కు సంబంధించి ఏరియాస్ గురించి తెలుసుకున్నాం కదా. మరి ఈరోజు ఎపిసోడ్లో న్యూమరికల్ ఇంటిగ్రేషన్ గురించి తెలుసుకుందాం. మరి ఈ టాపిక్ను మ్యాథ్స్ బోధనలో అపార అనుభవం గల చంద్రశేఖర్ గారు వివరిస్తారు.
We are taking up the chapter Numerical Integration, under which we are going to study the Trapezoidal Rule and Simpson Rule. First and foremost, let us see why we need this numerical integration. Why we need numerical integration is the fundamental theorem of integral calculus says a to b fx dx is equal to f of b minus f of a dx, f of a, when fx is the antiderivative or primitive of fx. This is the fundamental theorem of integral calculus, based on which we are doing definite integration. What happens when the fx cannot be found exactly? Then there is another approach, limit n tending to infinity, sigma r is equal to 1 to n, f of r by n is equal to 1 by n times 0 to 1 fx dx. This is known as integration as the sum of the limit. But at times neither this nor this are available to us. We cannot do either by finding the primitive or by integration as the sum of the limit. Then what we do? We will go for the approximation of the given integral, numerical approximation. There are various methods under numerical approximation, but in our syllabus there are only two methods of approximations. One is the trapezoidal rule, one is the Simpson rule. Both we are going to see, and we will do few questions on both methods in this session. Yes, first trapezoidal rule we are going to see. So let us recapitulate what we have done so far. Basically, the antiderivative, when it cannot be found or the integration as a sum of the limit cannot be done, then there is the procedure must be available to work out the integration. There the numerical integration comes in, and among the numerical integration there are various techniques. Among the techniques, first technique is the trapezoidal rule. The basic proof of this is beyond scope, and that is not needed also. What does the trapezoidal rule say? If fx is a function continuous on AB, divide AB interval into n equal parts of same length, that is h length of interval is equal to b minus a by n. So this is the length of the interval. So what we are doing now, we are taking up the interval starting from a going up to b. This is divided into equal parts, a to a0 to a2, a1 to a3, like that we are going to divide. h is equal to b minus a by n. Then let x naught is equal to a, x1 is equal to x1 is equal to a plus h. Okay, we are divided into how many pieces? N intervals. N interval, each length is h. So x1 is equal to a plus h, x2 is equal to a plus 2h, x3 is equal to a plus 3h, so on, and last block is xn. xn is equal to b. These are what? These are abscissae. Yes. Now, and let these be abscissae. Corresponding ordinates. What are the corresponding ordinate? When x is equal to x naught is substituted in the function, you are going to get y naught. Y naught is equal to f of x naught. So y1 is equal to f of x1. In generalized part, what you are going to get? yr is equal to f of xr. yr is equal to f of xr. Like that, yn is equal to f of xn. So these are what? Corresponding ordinates. Okay. Now, what is the trapezoidal rule says? You know, it says integral a to b fx dx is equal to h by 2 into y naught plus y1 yn, starting one plus the ending one plus the remaining ones. What are the remaining ones? The remaining ones begin from where? y1, go up to where? yn minus 1. So this is the trapezoidal rule of integration. They may ask us, describe the trapezoidal rule or give the trapezoidal rule for a very short answer question also. Okay, I repeat, what is the trapezoidal rule? Trapezoidal rule is nothing but numerical approximation of a to b fx dx. The interval a to b is broken up into n equal pieces. The length of the interval is b minus a by n, that is indicated by h. So you are having n abscissae. Corresponding to n abscissae, what you will have? You will have n ordinates. Take the ordinates and put them in this particular formula. You will get what? The numerical value of a to b fx dx. This is the trapezoidal rule. Next part, we are taking up the Simpson rule. Simpson rule. The Simpson rule and trapezoidal rule both are aiming at calculation of what? Calculation of a integral approximated, but definite integral approximated. But the basic difference is, in Simpson rule, the number of intervals into which the AB interval is divided must be even number of divisions. So the rules I am writing: let fx be continuous on interval AB. Divide the interval into n equal parts. N is equal to 2m even. This n is equal to